All right, guys, last page here. So we really want to take a look at what our problem is giving us, or after I write my equations from a story problem, what is the best way to solve our system? Okay, we have three different ways that we can solve. We can solve by graphing, we can solve by substitution or elimination, and there's sometimes a better way to do it. You can use any method that you want, but by better, what I mean, I guess, is a faster way to do it. And faster isn't always better, but sometimes we just want to get to our answer quickly, especially when there are so many steps. So to save on the amount of steps that I do, we want to really think about which way should I solve this in the least amount of steps possible. So I'm probably often not going to graph, but I could graph when both equations are in y equals mx plus b. I feel like if I'm both in y equals mx plus b, for example, like y equals 2x plus 1, then I can pretty quickly just graph, look for where they cross each other. But the trouble is sometimes they don't cross at nice spots like we saw in that one example way back when. Or sometimes they don't cross at small enough numbers. And if they cross at really big numbers, that can be a real pain in the butt to figure out. So that's why I sometimes avoid solve by graphing. So another way to do it is by substitution. So, you might use substitution actually when they're both in y equals mx plus b. But mainly we want to do this when one or both equations have x equals or y equals. So if they have a letter alone, one of them or both of them, substitution is kind of the easiest because you already have a letter alone. You can just inside substitution or do like left to right substitution where you put one on the left side and one on the right side. Now, I know elimination is kind of the phase because it's super easy to start, but you really only want to do elimination when your equations are in standard form. So like ax plus by equals c, or like x plus 2y equals 6, or something like that, okay? And actually even better yet when there's like a 3 in front of that, because it's not so hard to get x by itself if it didn't have the 3 on it, but if both your letters have numbers on them, or all your letters have numbers on them, probably elimination is best. However, like I said, any way you go about it, you should always get the same solution. Okay. Alrighty, so we just got a bunch of examples here to try, and I'm going to start off by probably solving it each way so that you can see that they're all the same. But maybe as we go on, if the video is getting really long, I won't solve them every way. I'll just solve them kind of the best way or the fastest way. Alrighty, my camera is all like goofy. There we go. All right. So 2 times a number x plus a number y equals -4. 3 times a number minus y equals -1. Okay, so I got to write some equations. That first sentence is talking about one equation. 2 times a number x plus a number y equals -4. That second one, that second sentence is also telling me an equation. 3 times a number, I think I forgot an x here. That's why I hesitated before. 3 times a number x minus y equals -1. So I'll tell you what, by taking a look at this system here, because these are both in standard form, I feel like elimination is best. Okay, so I would totally do elimination here. I would take my two equations, the 2x plus y equals -4, and 3x minus y equals -1. And as they are right now, if I add them up, the y's will eliminate because they are opposites. So I'll have 5x, 0y equals negative 5. Then divide the 5 both sides, so x is negative 1. And then you can pick either equation. I'm going to go with the top one just because there are less negatives. And in place of x, since I know that it's negative 1, I'll put it in and then solve for y. So 2 times negative 1 is negative 2. And then add that 2 over. Sorry, this is looking like a mess. I'm writing kind of like in midair. It's really ridiculous. Negative 4 plus 2 is negative 2. And so I have that my solution is negative 1 comma negative 2. Now, I'm not going to solve by substitution because that just seems silly, but I do want to show you how this shows up graphically. So if they're in standard form, I can actually leave them in standard form and graph. On that top one, if I ignore y and solve for x, I find that my x-intercept is negative 2 because I would divide both sides by 2. And then the y-intercept, if I ignore x, would be negative 4. So we get this line here. Oh my gosh, I need a straight edge. I can't do it. I was going to do it midair and it was going to be so bad. Here we go. Let's highlight that one so that we remember. This was that line. And then if I graph the next one, oof. If I ignore that and solve for x, you get that x is negative 1/3, which I can plot, but it's not going to be super nice. Like that's kind of a guess. And then if I look and solve for my y-intercept, it would be 1. So right here. So if we graph that line now, draw this with a straight edge. Oh my word. Dang, I am so impressed with myself right now. I did not think that was going to come out super nice. So I can see that those two lines are touching exactly at the spot that we found. This right here is at negative 1 comma negative 2. I wasn't sure because plotting that negative 1/3 was not like precise at all. Okay, let's try another one. So an online music app costs $1 and each song downloaded costs $3. A second app costs $5, but it's only 50 cents per song to download. Which app is more affordable? So guys, again, kind of there's this one story here about this app costing $1 and then each downloaded song is $3. So that's like a starting value and then an over and over again number. So that's really y equals mx plus b, where m, my over and over again number, was $3. And I had to pay that $1 to even get the app. But then there's this other app that costs $5, but it's only 50 cents per song. So again, that's like y equals mx plus b, where my over and over again number, my per song number, is 50 cents this time, or 0.5, but I do have to pay $5 to even get the app. So with this one, I really could graph or do substitution. Like I feel like either one is good, graphing or substitution. Now, graphing might suck because we might not find a precise answer, but like let's try it. Because they're both in y equals mx plus b. So this top one starts at 1 and has a slope of 3. So up 1, 2, 3 over 1 over 1. And so if I get my straight edge, I get this line here. And that's our green line. Versus the other one has a y-intercept of 5. So 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. And has a slope of half, which maybe that makes it weirder to graph about, but really half is just 1 over 2. So like up 1 over 2, up 1 over 2. And I kind of already feel like graphing was not the right way to go You're probably over there thinking like, Missouri, I could have told you that forever ago. Like nobody ever wants to graph, girl. I love graphing. The reason I say that this wasn't the way to go is because I can see that they are crossing, but it's just not a super nice number. So I really should have just done substitution. Because I have that y equals 3x plus 1 and y equals 0.5x plus 5, I can really do that left to right substitution because these are both equal to y. I can set them equal to each other. So we have 3x plus 1 equals 0.5x plus 5. We're going to want to get our x's on the same side. So I would subtract the smaller one, 0.5x. And 3 minus 0.5 will be 2.5. Look at me, keeping it a decimal. I was about to change it to a fraction, but I'll keep it for you. Then I would solve for x. I'd subtract the 1, both sides. So 2.5x equals 4. And then finally, I would divide by 2.5 to find that x is something. 8? No. 2? No. What is this? Where's my phone? Siri. Oh my gosh, this is embarrassing. I don't know what 4 divided by 2.5 is. 1.6. Oh my gosh, that makes so much sense too, because if I look here, it's like over 1 and a little extra. But now to figure out what y is, I'm going to have to plug it back into one of our two equations. So I'm going to go with that top one because it doesn't have the decimal. So y equals 3x plus 1. But because I know that x is 1.6, I can plug it in. So we'll have 3 times 1.6 plus 1. And 3 times 1.6 is, oh my gosh, 0.6 is 4.8. Duh. Sorry, decimals are not my thing. So 4.8 plus 1 is 5.8. So my solution is 1.6, comma 5.8. But, I mean, that didn't really answer the question, I suppose, because it is asking me which one is more affordable. So I feel like in the long run, the blue one will be more affordable. So yeah, it's a big cost right off the bat, but very quickly, the green one is costing you more. So the second app is better in the long run. Like after 2 songs, basically, it's instantly better. So, all right, let's try another. On that third one, in a clothing store, t-shirts cost $10 and sweatpants cost $15. If Autumn spends $220 after buying 16 items, how many did she buy of each? So there's a lot of questions that are kind of like this, guys, where I think we kind of talked about one like this in the other video that I posted. But this thing where we're talking about t-shirts costing some amount of money and sweatpants costing some amount of money and me spending a total of some amount of money, all the money equation or money numbers go together in one equation. And it's going to be standard form because for every t-shirt is $10. And for every sweatpants, it's $15. So we're looking at 10x plus 15y equals 220. Now, the reason that it's kind of confusing is because my second equation, I need to write it. It feels like it only has one number because we're saying that we bought 16 items. But I'm buying some t-shirts and some sweatpants. And when I buy them all together, there are 16 things. So really it's just x plus y equals 16 because we're doing t-shirts and sweatpants. Like I got some of them over here, some of them over there. When I add them all up, there's 16 of them. So I feel like for this one, I would probably do elimination. Yeah, I feel like I'd do elimination. Because it's in standard form. The only issue, the reason I hesitated is because I'm going to have to multiply by a real big number. Like I think I'm going to multiply the bottom one by a -10. Because then the x's will be the same. So I'm going to take that whole thing and times by a -10. Now I could also do a -15, but that's even bigger, so I don't want to do that. So bringing this over, the top equation stays the same. Bottom equation, we're going to times it by -10 now, so we'll have -10x minus 10y equals -160, and then we'll add it up. So 10x negative 10x is 0. 15y minus 10y is 5y. 220 minus 160 is going to be 80. And then we divide by 5. So y is 16. Right? 40. No, that's 60. I was like, that seems like a lot. And 5 goes into 60 12 times. That's still kind of a lot. But let's think about what this is. So y was the $15 item, which were the sweatpants. So I bought 12 sweatpants. And if you remember, like we bought 16 items. So if I bought 16 items, the other 4 needed to be t-shirts. Which I mean, I'm kind of like in my head plugging it in right here and subtracting the 12. But I feel like we really don't need to write it out. And it's getting real dark in here again. I'm going to turn the lights on. Now we could do substitution, but like, why? We're just going to do it the easiest way. So next one, at a bake sale, cookies cost 25 cents and brownies cost 35 cents. If Nathan spent $3.15 and bought 11 treats, how many of each item did he buy? So this equation, or these two equations are just like the last ones. We have that cookies are costing 25 cents, brownies are costing 35 cents, and we spent a total of $3.15. So that's a standard form equation where I'm going to use like better letters this time. Like I was a little bit confused at the end. And what I mean by that is I'm going to do like 25 cents per cookie and 35 cents per brownie for $3.15. And then the other equation uses that other number where I bought 11 treats. And some of them were cookies and some of them were brownies. So I just do cookies plus brownies equals 11. Now maybe what I'll do on this one, like I could do elimination again, just like the last one, but I'd have to multiply by a decimal and no thanks. So maybe I will do substitution on this one. I feel like it's pretty equivalent. Like I do have to do a little extra step. Like I'm going to subtract C to get B all by itself. So that is extra, but just so that you guys can see how either one would work. So this will go in for B because it's equal to B. So we'll have 0.25C plus 0.35. And then in for B, I'm going to put 11 minus C equals 315. Oh boy, I'm going to have to calculate again. So we'll have 0.25C, and then I have to distribute that 0.35 times 11. Decimals times 11 equals $3.85. But then the 0.35 times negative C, that's fine. So minus 0.35C equals 315. Sorry, I went off the page a little bit. Then I can combine like terms because these C's are on the same side. So 25C minus 35C is 10 cents, but negative. So negative 0.10C plus 385 equals 315. Then I'm going to start solving for C. So I'm going to subtract that 385. So we'll have negative 0.10C. And then when I subtract here, I'll have negative 0.70. And so when I divide the negative 10 on both sides, I think it's just going to be 7, right? Oh my God, the decimals. I can't. 0.7 divided by 0.1 is 7. I just had to double check. So C equals 7. Now, maybe it would have been easier with elimination, but I don't know. That's what I did. So the reason I use different letters here is because now I know what this means. I don't have to remember what X and Y stands for. I remember that we're talking about cookies. So I had 7 cookies, and I bought a total of 11 treats. So that means I must have bought 4 brownies to have a total of 11. Now, really what I'm doing there is like in my head, low key thinking like 11 minus 7 is 4. But I feel like you really don't need to plug it in. Like you probably just know. Alrighty, 2 more. We can do it. I know this video is epic, but if you're feeling good, you could stop it here. All right, a medium pie at Olivia's Pizza Shop costs $6.80 plus 90 cents per topping. A medium pie at Nathan's Pizza Shop costs $7.30 plus 65 cents per topping. So even though these are money numbers, guys, I think I only have one over and over again number. Like at Olivia's Pizza Shop, I have to pay $6.80 plus 90 cents per topping. So I think that's a y equals mx plus b thing. Like y equals 680 plus 90 cents per topping. Like, why not? Let's just call it T. And then the other one, I have a different pizza shop where it costs me $7.30 plus 65 cents per topping. So it's like one shop costs one thing plus toppings, and then a different shop, so a different equation, costs a different amount plus 65 cents per topping. Now, I probably would not graph this because those decimals are real yuck. I would probably just do substitution. And I didn't even put elimination on here, but I wouldn't use elimination because it's not in standard form. So because they're both equal to y, I can set them equal to each other. So I'll have 680 plus 90t equals 730 plus 0.65t. I'm going to want to subtract to get my t's on the same side. And I'm going to subtract the smaller one. So we'll have 680 plus, let's see, 25.25 t equals 730. I'll subtract my 680 both sides to try to get t alone. So I'll have 0.25 t equals, what is that, 50 cents? Yeah. And then divide that 0.25, and that's going to go 2 times. So once I get to 2 toppings, so at 2 toppings, the pizzas cost the same. And if I wanted to figure out how much they did cost, I would just have to plug it in. Like I would do over here 730 plus 0.65 times 2. Or I could do over here like 680 plus 0.9 times 2, which that one to me feels a little easier, like 680 plus $1.80 is 820. Nope, 860. But I'm going to get the same thing over here, and then they cost that 860 for the pizza at either shop. Okay, last but not least, Nathan and Olivia decide to go bowling. The cost for Nathan to play is $4 per game, plus $2 to rent the shoes. The cost for Olivia to play is $5 per game, but only $1 for shoes. So again, I think this is kind of like the last one where I have to pay $4 per game plus the $2 to get the shoes. But for Olivia, I guess, I don't know, for girls it's different. I don't know. For her to play, it's $5 per game, but only $1 to buy the shoes. So I think like y equals mx plus b again. For the first one, it's $4 per game plus $2 to rent the shoes. For Olivia, for girls, apparently it's $5 per game, but only $1 for the shoes. So I feel like our best bet is to either graph or do substitution like we did on the last one. And just for funsies, because I love graphing so much, I'm going to end with a graph. So this top one, I would start at 2 and then do a slope of 4. So up 1, 2, 3, 4 over 1. Get my straight edge. And then for that bottom one, I would start my y-intercept at 1 and then do a slope of 5. So up 1, 2, 3, 4, 5 over 1. Ooh, look at that. They cost the same amount right there. Now, guys, I probably should have mentioned this on the last one. Gosh, those are close together because their slopes are super the same. We do want to think about what our like x and our y mean. And I kind of talked about it there with the toppings. But for this one, x is talking about the number of games. And then the y is talking about how much it costs. So right here where they meet, which is at 1, 1, 2, 3, 4, 5, 6. This means that after one game, the cost for Olivia and Nathan is the same, and the cost is $6. Right? And we can kind of make sense of that too. Like if I play one game, it's $6. If I play one game, it's $6. So yeah, yay, story problems aren't so bad. It's going to be fine. I'll see you later. Good luck.